Okay, today we are going to look at application of Gauss-Seidel to the BTCS scheme. Okay, so we had this equation and we had the interior points and like that. So let me just give you the details of the problem we are going to solve. So here top boundary is k dt dy plus h t minus t infinity is equals to 0. Every problem is different with respect to uh, its boundary condition. Okay, so say these boundary conditions are given. So with this given boundary condition and the governing equation, so for interior points, if you discretize this domain into various subdomains, that is, you generate a grid, then these are all interior points that we have already noted. So for these interior points, for interior points, what is our equation? Our equation would look like Tij n plus 1 backward in time, where Tij n delta t many times in the exam I have seen that some students are writing it like a, okay, while me writing, my writing pad might skid, so it may not look like a delta, but this is a delta. Remember, those who are not, you know, please listen. At least listen to the classes. What does mean by one, uh, notation or something like this delta t. And then we have all these terms at n plus 1. Okay. So ti plus 1, comma j minus 2 tij plus ti minus 1, comma j divided by delta x square plus ti j plus 1 minus 2 tij plus ti j minus 1 delta y square. where I is running from 2 to nx minus 1. Okay, this is final point is nx and starting point n, starting point n and last point ny. So this point is nx ny, isn't it? This point will be nx ny like this, and ny minus 1. So from 2 to where I is running from 2 to nx minus 1 and j is running from 2 to ny minus 1. Now we'll talk about these boundary conditions, boundary points. So boundary points, left boundary. What is left boundary? It is a um, so we have to take forward difference. So T2 j n plus 1 minus T1j, T2j minus T1j divided by delta x is equals to 0. So this finally gives you T2j is equals to T1j n plus 1. And this is for j is equals to left means I is equals to 1 and j is equals to 1 to ny and I is equals to 1. Now let us take bottom boundary condition. So at the bottom you have this again. So what will do? You will take the forward difference. So what is the inner points and what are the boundary points? So boundary point means I will be varying. So T I 2 Ti2 n plus 1 is equals to Ti1 Ti1 n plus 1. And this is for I is equals to 1 to nx. And already I have written j is equals to uh, 1 2 and j is equals to 1 2. Already written, so no need to write j is equals to. This may not be necessary because already we have written index, fixed index for j. J is not I is not varying here, j is not varying here. Already written here. Okay. Now let us come to top boundary condition. So top, we have a one gradient term in the top boundary condition, that is del t del y, k del t del y. So k and del t del y. So at the top you can use a backward difference. So t I comma n y minus t I comma n y minus 1. This is the backward point and all this should be n plus 1, n plus 1. And this is delta y. Please note this del is delta. Don't write it like a. Those who are just copying in the exam. Don't just open the notes during the exam. You do it T I n y n plus 1. Okay. T I n y minus T infinity is there. So H is multiplying in the bracket. So it will go H T infinity. T infinity is a fixed value. So we will not represent by index. This is a known value. And this has to be done for I is equals to, for I is varying. So for I is equals to 2 to ny. Okay. Already we have given boundary condition for 1. So we are starting with 2. Already we have given these boundary conditions. So we have already given boundary condition up to ny. So we are starting with 2 and we are giving boundary conditions here. Here, 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 and here. This is something like a common point to these two boundaries. Del t del x also is equals to 0. K del t plus h t minus t infinity is equals to also 0 at this corner points. Okay, so corner point is something, but it doesn't bring any difficulty in the solution. So you can go like this. Then about right boundary condition. So right boundary condition also can be written like that. But here also you have to use backward difference and your indexing will be nx and j minus t nx minus 1 comma j n plus 1 divided by delta y delta x, sorry, delta x, isn't it? This is delta x plus h t nx j n plus 1 is equals to h t infinity n plus 1, and this should be for j is equals to 2 to ny minus 1. Okay, ny minus 1. Ny minus 1 means
Sir,
uh,
sir, for top boundary condition, I should vary from 2 to nx, right? Not ny.
which one?
Top boundary condition. I should be varying from 2 to nx, right? And not ny.
Ah, yes, nx. Yeah. Okay. So this here we are starting with 2 to n y minus 1. Okay. This is LO. 2 to ny minus 1.
Sir,
Hmm.
sir, one doubt, sir. In left boundary and bottom boundary,
Ah.
in left boundary, j is running from 1 to ny.
Ah.
If we take j is equal to 2, then
Ah.
t22
Ah.
is equal to t12.
T22 is equals to T12.
T22 is
T22 is
T22
this
is
one.
interior point, na?
It's okay. We need to give the slope. We need to give the derivative. That is how we are taking backward difference. How will define a derivative over here? At this point, how will define the derivative? So at this point,
We have only interior point value.
del t del x, at this point, del t del x, suppose this is a I point, so this will be a I plus 1 point. So del t del x at I is nothing but equals to this delta you have to represent using forward difference. Okay. So what will be a forward difference at I? T I minus T I plus 1 or T I plus 1 minus T I divided by delta x. So you will get one interior point. Then only you are able to get this value.
Okay, sir.
Okay. But T2J is a T. Okay, you write like this. If your doubt is like this, then you can write like this. Okay. 1J, 2J you can make like this. But it should be understood. If you are very careful about that, then you can write like this. T1J is equals to T2J. Okay. Here also you can write like Ti1 is equals to Ti2. Okay, right boundary condition. Okay. Then what are the central coefficients that we have to note? Hmm. No, J right boundary J should vary, na? J should vary. 2 to ny minus 1. 2 to ny minus 1. For for left boundary, we are varying from 1 to ny. Okay. For bottom boundary condition, we are varying from 2 to nx. Okay. Because this is a common point to two boundary conditions. So at least one boundary you will have to assign, and then here other boundary. If you assign two boundary conditions, either will be swapped, isn't it? So since boundary is given, we are starting with 2 to nx, and here we are starting with 2 to ny minus 1. Okay, such a way that all points are covered. That is our objective. All boundary points should be covered. Okay. Now our job is to find out central coefficients. Okay, for Gauss-Seidel, we want central coefficients. So let me write equations, numbers, then we can make it easy. So from this equation, which we can
Sir,
call equation number 1,
sir,
and we,
sir, sorry, sir, that left boundary condition I after that change I am not able to understand, sir. That
which one? This one?
left boundary condition.
Left boundary, this one?
Yes, sir.
Why, what is here? Here you have these 2 points, okay, isn't it? This is interior point, this is boundary point,
Yes, sir.
this is interior point. So here you are taking a forward difference. So T interior minus T boundary divided by delta x, whatever delta x they have, should be equals to 0. This means that boundary, temperature boundary should be is equals to interior.
Yes, sir.
So T1j is a boundary point, isn't it? T1j n plus 1 is a boundary point, should be equals to interior point. That is the meaning of del T by del x is equals to 0. Then
Yes.
only del T by del x will be 0.
Okay, sir. So
Okay.
that T2J, that 2 remains same. That total.
Okay.
Okay.
Because 2 is fixed. I is equals to 2, isn't it?
Yes, sir.
This I is fixed. J is varying. Here I is fixed. J is varying. Okay.
Yes, sir.
Yeah. And why this delta T delta X should be 0? Suppose here the interior point value is 50 degrees Celsius. So what value of the boundary point will make del T del X 0, delta T del or delta T delta X is equals to 0? Delta T should be 50 minus 50. Then only it will be 0, isn't it?
Yes, sir.
Yeah. So that is the meaning. So meaning is whatever the boundary value is, it should be equals to the interior value. Then only del T by del X is equals to 0. Okay, central coefficients from equation 1. From equation 1, what are the central coefficients? What is the central term? Tij, isn't it? So here Tij is, first Tij is, if you bring this delta T here, alpha delta T, then we have 1. Then if you write alpha delta T delta X square as a gamma X, then it will be 1 plus 2 gamma X. Are you getting this? 1 plus 2 gamma X plus 2 gamma y, where gamma x is equals to alpha delta t delta x square, and gamma y will be equals to alpha delta t delta y square. While writing, just a minute, while writing this thing you can write in a reverse manner, but while assigning in a computer program, always right hand side will be assigned in left hand side. Okay, so it is okay to appropriately write like this. Okay, from equation 1, this will be there, is it? So this is a coefficient, one coefficient is here, and this 2 will go left hand side, or this side, it will go left hand side, so it will become positive alpha delta t delta x, gamma x, and gamma y. From equation 2, what is the central coefficient? What is the central coefficient? First you have to identify, say in first, Tij is a central variable, the variable under consideration. Interior points means Ij are the interior points. So this is only a Tij is the only point under consideration or node under consideration. Now in left boundary condition, which is the point under consideration? For left boundary condition, which is a point under consideration? T. For left boundary, right? This is a left boundary. This is 1 and 1 to ny minus 1, isn't it? This is j and this is I. Which one is a point under consideration? A boundary point is point under consideration. This point, isn't it? These points. And these points are represented by T1, J. Are you getting? T1J. I is equals to 1 is a boundary. I1, this is 1. This is 1. Okay. This is 1. Are you getting or not? Are you getting? Okay. So, what is the coefficient of the point under consideration? What is its coefficient? 1 only, isn't it?
Sir,
Hmm.
for boundary node under consideration, you tell that all the points on the I. Then that will be the central coefficient for the boundary.
Pardon?
You tell that, sir, ki boundary at the left boundary from 1 to j, those are the point under consideration. So that itself are the central coefficients.
So there, what are their coefficients? We are interested in coefficients.
Yes.
What is their coefficient?
1.
1. But you have to write this properly. Okay. If you write this equation has to be written in this form. T2j. This is forward difference, isn't it?
Yes.
T2j minus T1j n plus 1 is equals to 0. Now, from this equation, you have to find out the coefficient. This is appropriate. Okay. What I have done here is, I have taken these terms there. But this is delta t, delta x. Delta x gone here, so 0.
Yes.
So now the coefficient is what coefficient do you see here?
1.
-1.
Yeah, sorry, 1 minus
Yeah.
1.
So here AII is 1 plus, AII is -1. Okay.
Sir,
Similarly here also.
sir,
Here also TI2 n plus 1 minus TI 1 n plus 1 is equals to 0. You should not be taking this thing out, okay? Otherwise, then left and right hand side, because ni plus 1 should be all these ni plus 1 terms. What we are doing over here also, these all ni plus 1 terms we are putting in the left hand side. Then only we are taking their central coefficients.
Yes,
okay,
sir.
sir.
So you have to bring this into the left hand side, bring this into left hand side, and then take the central coefficient. Okay.
Yes, sir. In that left boundary is there, no, sir.
Hmm.
But there, if we put j as 2, then we have +1 as coefficient, no, sir. So +1 -1 is coming, sir. Both
Huh? No, +1 -1 will not come.
in left condition. If
Huh.
j is 2, then t22 coefficient will be 1, no?
No, not t to 2. Just central coefficient. What is central coefficient? Central coefficient is the coefficient of the term which is, under consideration. Now here it's not AII, it should be, we will not write like AII, it should be A1J. Okay.
Yes, sir. Okay, sir.
Okay.
Sir, one more question.
Huh.
Then the diagonal. This means that central elements are not necessarily the only diagonal element. Correct, sir? Is it correct? Because
Not exactly. This will actually come as a diagonal. No, you cannot say that it is the coefficient of the term which is under consideration. Okay. Now, say you are talking about interior points, then all interior points doesn't have this, AII only. Okay, not diagonal only. So every point is IJ point, isn't it?
yes.
Yeah, it is a generalized point. So every point can become IJ points. So what are the coefficient of the this thing point under consideration? But we have already found from our matrix that these terms will come to only to that diagonal terms, isn't it?
Yes.
Yeah. So from this you can say in some sense for interior points they can be a diagonal, but for
Okay.
boundary they may not be diagonal.
Okay. Yes, sir. That is the confusion actually. Thank you, sir.
So that is the reason I'm not saying only IJ. What I'm saying that point under consideration.
Yes, 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 sir.
So point under consideration here is IJ, and here the point under consideration is T1J. Now in the second bottom boundary condition, point under consideration is TI1. And what is the coefficient of TI1?
-1.
-1. So again, TI1 is equals to -1. This is from equation number 3. And from equation number 4, what is our point under consideration? Top. For top, what is your point under consideration? So this is our top and y, isn't it? and 1 to ny and 1 to nx. Tell me.
1 ny, sir.
1 ny. But also others also should speak. 1 ny, isn't it? So wherever 1 ny is there, I mean I ny, not 1 ny, I ny. Ny is a top boundary, isn't it? Ny is this top boundary, but at top boundaries there are these points, and these points are represented by I, isn't it? 1 to nx. I should be varying from 2 to nx or 1 to nx. Okay. So TINY, 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 these are the central, points under consideration. And what are their coefficients? K delta Y plus H. Isn't it? The coefficient of TINY n plus 1 is K plus K delta X, delta Y plus H. And from equation 5, what is the central coefficient for the right boundary? Right boundary is nothing but nx. Yeah, nx. And j is varying. So nxj, this is nxj boundary. So what are the nxj points are there? Those will be, so these nxj points, nxj. And what are the coefficients of this nxj? K delta x plus h. K divided by delta x plus h. Okay, so we got the coefficients, okay, central coefficients. Now our job is to find out residuals, corresponding residuals. And we have said that residual is equals to right hand side minus left hand side. So following this rule, from first equation we can get R is equals to Tij n plus gamma y Ti j minus 1 n plus 1 plus gamma x Ti minus 1 comma j n plus 1 minus 1 plus 2 gamma x plus 2 gamma y Tij n plus 1 plus gamma x Ti plus 1 comma j n plus 1 plus gamma y Ti minus 1 comma j n plus 1. I minus 1 is already, okay, sorry. I j plus 1, j plus 1. Okay, Ij. Okay, so what we have done is, we have taken RHS minus LHS and we have said that this is our residual. And then next residual, this is from equation 1. From equation 2, residual R is equals to T1j n plus 1 minus T2j n plus 1. From equation 3, residual R is equals to Ti1 n plus 1 minus Ti2 n plus 1. Is it fine? Okay. What will be from equation number 4? Just tell me someone. What will be from equation number 4? H t infinity n plus 1. Tell me.
minus HTI
Minus h t
I n plus
I
1
n
ny.
y n y. Isn't
Yes,
it? N plus 1. Then minus k and all this. Ni, ny minus ni. I mean n ti ny minus 1 and n plus 1. Delta y. Right? From equation 5, r will be equals to h t infinity n plus 1 minus h t nx j n plus 1 minus k t nx j n plus 1 minus t nx minus 1 j n plus 1 divided by delta x. Okay, so we got a terms coefficients and we got corresponding residuals. Okay, so now how do we solve? So I'll just give you an algorithm to solve. So first thing is you have to initialize delta x, delta y, delta t, nx, what are your nx values, ny, etc. And create some t old array of size nx and y, two-dimensional array, and t new of again nx and y size, two-dimensional. And you can assign n is equals to 0. N is our variable, time variable, and you can assign at n is equals to 0 t old nx and y as an initial condition. nx and y as initial condition. What are the initial condition is? This is initial condition. Okay. This will be given initial condition. Given initial condition. Then you have to guess. Okay, first guess. Because this is an iterative process, so you should have a first guess. First guess will be, we'll say that t new is equals to t old. So what is our guess? T naught. We say t old is equals to t naught. So this is our initial condition. And as a guess, we say that t new values will be t old. Whatever the initial conditions are there, let those be first guess. And then we start a sweep. Sweeping means looping. Okay, sweep over all points. Sweep means loop over all points. All points means interior as well as boundary points. Interior plus boundary points. Getting this? How do we sweep? Using a for loop. Okay, using a for loop. So using a for loop for ij, okay, you have to find out r. Okay, this r for each find r for find r. Okay, for rj means each point, full stop. For ij, you write capital. For ij, find r using r, sorry, t new, using r equations obtained. So shall we write them as a some sort of numbering? If you give them as numbering, so 1, 2, 3, 4, 5, we can say this as 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 11 to 15. Equations 11 to 15. Okay. Obtain t new, which will be ij. This will be two-dimensional array, is equals to t new ij. So to obtain this, we have to again use for loop for ij. Plus, then these all r values will be stored. So r divided by a central coefficient. So corresponding central coefficient you can put. So for every interior points, you will write r is corresponding central coefficient. Okay, when I'm writing aii, doesn't mean that it only aii. In case of boundary point, whatever the central coefficient is there, you have to put here. Okay, now while doing this, use this for loop for for ij. This ij for ij, say use for interior. Okay. Similarly, you write. So if I expand for ij, left boundary, left BC. Same equation, T new ij. Ij means you can write corresponding I, because I is fixed in left, so it can be 1, comma j is equals to T new 1, comma j plus whatever r is there and a 1 j. This r is a left boundary r. Okay, left boundary, and this is rii, you can say. Or if I have to write, this can be r1j. Okay, then again you write another loop, for loop. So I will write, this will be a nesting loop for I, then within that for loop there will be a j loop. You understand this, right? Then left, right. Okay, so do t new. So right means it is nx and j is varying, nxj. T new nx j plus r nxj a nxj. Then for ij, that is bottom. So you have to write each loop here. That is very important. for ij, so j I is varying, so I and n bottom, so this is I1 T new I1 plus R I1 divided by A I1, and for ij left right bottom top T new will be equals to I and y is equals to T new I and y plus R I and y divided by A I and y. Okay, so this way you will obtain using each loop these values, and then if next will be so next will be a for if RMS RMS residual RMS, and we have already shown how to calculate RMS is greater than epsilon, then go to step 3. Then go to step 3. I have written step 3 here, right? This step 3. Are you writing this? Otherwise,
Yes,
it will be difficult. Huh? You are writing this, right? Have you written this?
yes, sir.
Okay.
Yes, sir.
Yes, sir.
Because it will be helpful for you to write program. Huh? So then go to step 3. So keep on calculating these values. Else, if not, this condition is not satisfied, means residual is not 0, then else, this residual is still greater than 0. So you keep on calculating. And if it becomes 0, else means if it becomes 0, then else print the values of T new. Print T new ij values. All ij, okay, interior as well as boundary, if needed. If needed, you can write n is equals to n plus 1 and t is equals to t plus delta t, and you can write also t old. It depends, how you design your program. T old should be equals to T new ij. This might be needed. T old and T new, it might be needed because you may be using T old and T new variable. Say for example here this n means old, n plus 1 means new. So next time Tn, after the first iteration, the n value will be the first iteration value, but while during the first iteration this value is unknown, but second iteration this value is known. Okay, so you have to keep on updating. So T old will be T new in second iteration. You understand this? So what I'm saying is, suppose you are at T and you are moving at T is equals to 1. So when you are calculating T is equals to 1, these are all known values. These are nth level values and these are n plus 1th level values. Now, if I am calculating T is equals to 2, now this should be n. So n plus 1 should become n and this should become n plus 1. Isn't it? So T new should be equals to, or T old should be equals to T new to calculate these values. Okay. So that if you go to T is equals to 3, again this value should become old value. To calculate this new value, this should be n plus 1. So essentially this should become, in order to use this loop continuously, same equation continuously. Okay. So in that case, you might have to just use this container T old, where you will be storing T new values. so that in the next loop that equation will not affect. Okay, so that is the logic. If stopping criteria is not satisfied, now this stopping criteria is time stepping criteria. Okay, is not satisfied, then return to 2. What is 2? First guess. Okay, we are still at first guess. You understand? So this is t is equals to 0. This is initial condition. Initial condition is given. Now t is equals to 1 is being calculated. So while calculating t is equals to 1 itself, we have a lot of iteration. This process is going on. Okay. So once this residual is 0, then only we say that we got this new value n plus 1. Are you getting this? Here will be a lot of iteration.
Sir, this
This
time
iteration,
stepping.
this sweeping will
No.
be keep on going when till RMS value become 0. If RMS value is 0, then we will say that t is equals to 1, these are the values. Okay. Then we will move to next guess. So at that time we will say that my guess for t is equals to 2 is t is equals to 1. Okay. So to calculate this value, these will be the guess value, updated guesses. Previously these were the guess, isn't it? Are you getting this? Are you getting this? Now here for t is equals to 2, you will do all this R calculation, and here you will do in looping. This ij looping will be keep on going. Okay, you understand this? So this is this one is a outer loop. This is called as outer loop. While this one, this sweeping loop, is an interior loop. There are two loops, two criteria. Outer loop criteria, if stopping criteria, outer loop criteria can be whatever the value at T2, suppose T2 value, T is equals to 2 value, minus 1 value, difference between these two values is small, then we say that stop the outer loop. No need to guess. Means we got the solution. You understand? This is outer loop. But still inside that we want to find out what are the, from these guess values, what are the values at t is equals to 1. And those are the values for which the residual is 0. Residual becomes 0. Those are the values of t at t is equals to 1. Similarly, we find what are the values at t is equals to 2. And every time stepping, we keep on checking whether I got a converged results or not. Means while I am going to t is equals to 3, again I will calculate values. We will do that residual calculations. Once residual falls, I will note down the values and check whether T3 minus T2 values are changing or not. If they are not changing, means they converge. We got the result. Stop. No need to do further calculations. So outer loop is for time loop. Inner loop is for getting the interior values. Are you getting this? Can you imagine this?
Sir, if suppose the problem is not time dependent, then we don't have to go for that outer loop, na?
That is a good question. But have you understood what I am doing?
Yes, sir.
Yeah. Now the answer to that question is, even if there is no time derivative, as I told earlier, there is an approach called as false transient approach.
Yes.
So you will always use false transient. Means there will be a
Yes.
time,
Okay.
we will not say that we are moving in a time like that, but it is a iteration loop, outer iteration loop. First iteration, second iteration, like that we'll say. But within that iteration, there are many iterations.
Yes.
These are interior loops.
Yes, sir. Got it.
Yeah.
Yeah. So
If you go for this third part is not there. Explicit means you just simply calculate the values. But there is outer loop. There is no inner loop. Inner
yes,
loop means there is no checking loop, condition loop. There is just a calculation loop.
because all the values are known to us. There is only one unknown. That's all.
Yes, so just we substitute and calculate.
Yes, sir.
Here we guess and then find out. So we guess that these are my values, then what should be my T2 values? These guess values, then what should be my T1 values? If T is equals to 0, at T is equals to 0, these are my guess values, what should be my T is equals to 1 value? So those are the values for which residual falls to 0. Okay. So that
Yes,
is
sir.
how we are doing here. So at a situation where residual falls 0, those are the temperature values. Those are the updated guesses. Okay.
Yes.
Yeah. So, okay, I think we also write like this. Okay. And then just last statement, print. Print the final solution. You understand? Print the final solution.
Yes.
Final solution is the one where we have this stopping criteria. Means suppose temperature values you got here, temperature, all temperature values 500, 500, 500, and here also you got like 500, 500. Then what do you see? There is no variation between T2 and T1, T3. We said that we reach to some condition. So no variation. So converged. No variation from the previous and present time. So we got converged result. So that moment we will print these values, converged value here, these values. Okay, not this value. You print the current value, current level value. Why to go to back again? Print final solution. Okay. So here the stopping criteria, I'll just write it here. What I can write is, you can say delta T, RMS delta T can be written as summation. So root mean square, we can say T new minus T old, isn't it? This is a new time value, previous time value, uska square and sum divided by total number of points, n points, nx, ny. N points means this is nothing but nx, ny. Nx multiplied by ny. And if you can put condition like if this RMS delta T, RMS delta T means temperature, and also you can divide it by time because you are moving in a time step. So here only n points came into picture, but what about the condition for time stepping? So RMS delta T divided by time should be less than some epsilon. Epsilon is a small number like 10 to the power minus 5, 10 to the power minus 8 or anything, But you cannot take 10 to the power minus 20 because 10 to the power minus 20 means, I mean, it depends upon your computer, 32-bit, 64-bit. It can take only those numbers. Okay. So minus 2, minus 4 is also fine. Minus 3 is also fine. Getting minus 3, minus 4, This is also fine, but this may not be very accurate. This will be very accurate. This will be little less accurate. Okay, so this is what the loop is. If anybody is having a problem, please ask me, because our next assignment will be based on this only. This is the algorithm you have to code. You have to write a program for it. So outer loop means, here initialization means, again while initializing you have to initialize this array, and initialization of array in C is done by using for loop. Okay, for I, j you can do this initialization, and guess values also to be initialized for all ij points. So again you will have to use loop here for first guess. Then here you will put a loop condition, that is while this RMS delta t is greater than 0, you do these things. So again when you go here, you will say while, that first while is here, while RMS greater than some epsilon, do these calculations. So do these calculations for interior points, Rij calculations, and
Sir,
like that.
sir, sorry to disturb. Sorry
Yeah,
to interrupt,
time
sir.
is
We
over.
have a max class now,
Okay.
sir. Yeah.
Okay. Okay. Chalo, bye bye.
Hello, sir. Hello, sir.
Yes, Suraj.
Sir, I
Yeah,
have
hey.
one regarding this computer
Yes,
assignment,
come
sir.
to the doubt. Okay, come to the
Okay, sir.
doubt.
Sir, in the assignment problem, sir, in the explicit method, sir, we need the value of